This is a triac, and this one too. And today we're going to see everything you can do with this component. Welcome. This is Professor Nelson from Electronics. Now, what is a triac really? Well, a TRIAC is an electronic switch that allows you to control all devices that run on alternating current. And its appearance or size will depend greatly on the current and voltage you're using. Therefore, a TRIAC behaves like this switch, which will allow you to turn on and off any device that runs on alternating current, like this light bulb. It could also be a motor, a fan, or any device that connects to alternating current. Triacs have many advantages, and we'll be talking about them throughout the video. But one of the great advantages it has over its predecessors is, I'm talking about relays, which were used before the invention of triacs. Triacs are components that don't generate sparks when they turn something on or off. Unlike relays, which usually generate sparks on their contacts. These generate soot and, in turn, generate heat, causing the contacts to melt, damaging the relay. Therefore, relays tended to have a fairly short lifespan compared to triacs, which can last much, much longer. And in this video, we're going to learn everything you can do with a triac. Therefore, I invite you to stay until the end to see all of this. Without further ado, let's continue. Now, as a first example, we are going to look at this circuit, which is a dimmer, in which we can see that we have the triac as a variable resistor. However, in this case, it's functioning as an electronic switch. So, let's see how it does that in the circuit. We can see that we have a protection resistor. Then, we have a 200 kilo potentiometer, which will limit the charging current to the capacitors. In other words, it controls the speed at which the capacitors charge. These capacitors, in turn, have a DIAC connected to them. This is a DJC. A DIAC is a diode that operates with alternating current. This component is activated when the voltage between its terminals is greater than approximately 32 volts. In other words, when the capacitors charge and exceed 32 volts, it will activate like a switch, activating the triac. In turn, the triac will deliver the necessary current to the light bulb or motor. Now, let's see how it works with this graph. Here, we have the sinusoidal signal from the power outlet. And here we can see that the signal is clipped, both in the positive half cycle and in the negative half cycle. This clipping is achieved thanks to the activation of the diac and the rest of the components. As you can see here, we have a voltage increase and suddenly we have a voltage drop. It's at this point that the voltage at the ends of the DIAC exceeds 32 volts, causing it to activate. This current then activates the triac, allowing current to flow to the light bulb. What's delivered to the light bulb in this case is a fraction of the original signal. And this fraction will depend greatly on the position of the potentiometer. Therefore, the potentiometer will control the charging and discharging speed of the capacitors, and these will control the activation of the DIAC. And this is how this circuit works. Now let's see how it works in practice. Very well. Now let's test our first board. To do this, we'll set our multimeter to AC voltage so we can observe the voltage falling across our light bulb. Now we connect our board to the power outlet. And we can see that we have 10 volts. And the filament is starting to glow. There, we can see that the brightness has just increased much more. And the voltage has also just increased. In this way, you can also vary not only the brightness of a light bulb, but also the speed of a universal motor. You can also control the temperature of a soldering iron, a room, or any other piece of equipment. As you've just seen, the electronic board is working correctly. So now let's move on to the next board. Very well. Now let's analyze this circuit. This is a solid-state relay, and it works very similarly to a normal relay, like this one here. But with the difference that in this circuit, nothing moves. Here we can see that we have 2 triacs and 2 optocouplers. So, we have 2 of this circuit on this board. Now let's see how the circuit works. On one hand, we have 5 volts, and when we close the switch, this LED inside this optocoupler will light up. Here, we have an optotriac, meaning inside it, we have an LED and a low-power triac. This LED will activate the triac, allowing a small current to pass through, which will activate the higher power triac. This will power the light bulb or motor connected to it. We have a 470 ohm resistor that limits the current passing through the low power triac. Likewise, on the low power side, we have a resistor that limits the current, and an external LED that allows us to see when this LED has been activated. This is how this circuit works. It's much simpler than the previous circuit. Very good. Now let's test the circuit to see how it actually works. Now let's test our electronic board or solid-state relay. Since the board has 2 outputs, we're going to connect a light bulb to one of them. However, you could connect a solenoid valve or a motor to it. To the other output, we will connect our multimeter to be able to see the voltage that the plate gives us. The multimeter must be set to AC voltage. And as a control signal, we're going to use a 5-volt signal, as indicated in the circuit. Here we can see that we have 5 volts, which will activate the optocoupler and thus activate the output. In the module, we have the negative as the common, so we're going to deliver a positive signal to any of the outputs. We connect the board to the power outlet. Let's turn on the light. Now let's activate the output to the multimeter. And we have 222 volts. And as you can see, we have a status LED here. This LED tells us that the output has just been activated. This is how a solid-state relay works, with the advantage that it doesn't suffer mechanical wear, as is the case with normal relays. Very well. Now let's move on to the last board. Finally, we have this electronic board, which is much more complex than these two. However, this board works similarly to these two, but it's as if the two circuits had been joined into a single board. That is, this board can turn a light bulb or a motor on and off, but it can also vary the brightness or speed. Broadly speaking, this works like this. The voltage for the light bulb or motor enters this circuit. This voltage also functions as a signal that passes through the diodes and reaches the optotransistor. The optotransistor delivers that signal to one of these contacts. And through one of those same contacts, a signal enters through an LED, and it reaches the TRIAC, activating the light bulb or motor. This board needs a controller to work, meaning it requires an Arduino Uno or another type of controller. Therefore, it requires a program to work, which is why this board is much more complex than these. However, it is much more stable and reliable. You can do almost anything with this board. Now, let's test its operation. Now to finish, we are going to test the plate. At this moment, it is connected to the Arduino Uno, and the control will be done through two push buttons. At this moment, the electronic board is not connected to the power outlet. However, you can see that there is an LED lit here, which is the signal provided by the Arduino. When we connect the hob to the power outlet, this LED will light up, indicating that it's connected. As you can see, it has just turned on, and you can see that the bulb's filament is glowing dimly. Let's increase the brightness with the push button. This way, you can vary the brightness of a bulb, the speed of a motor, or the temperature of a device. But the best part is that you can do it digitally. You can use the controller to determine the temperature or brightness you need at any given time. And not only that, but you can use your phone to control which devices are going to be turned on using any application. That is, you turn it on through your phone and it will turn on the light bulb or the air conditioner or a motor or whatever you want. And all thanks to a TRIAC. In other words, all thanks to this component. And as you can see, this component is quite useful. Okay guys, that's how the video ends. Now don't forget that if you like the video, a like helps the channel a lot. See you in the next video. Bye bye.